Welcome to the secondary flight controls lesson in the PMDG 737 Next Generation Groundwork from Angle of Attack. This lesson will cover the following topics: general overview of flaps, slats, and spoilers, 737 NGX flaps and slats system description, flaps and slats protection mechanisms, flight and ground spoilers system description, spoilers protection mechanisms, and a lesson summary. Flaps are movable devices in an aircraft's wing that modify the wing shape to achieve extra lift and reduce the aircraft's stalling speed during low airspeed operation, such as while taking off or landing. Flaps may come in various forms and shapes, but they commonly extend aft of the trailing edge of the wing. Like this, the total wing area increases and there's higher room for generation of lift. Slats also are movable devices, however, on the aircraft's leading edge of the wing that change the wing shape to achieve extra lift. They commonly extend forward of the wing's leading edge. Slats are also available to reduce the aircraft's stalling speed during low airspeed and high angle of attack operation. This is done by smoothing airflow in the upper surface of the wing during high angles of attack, therefore generating more lift. Angle of attack is defined as the acute angle between the wing chord line and the relative wind. Slats have a higher field of action in the inboard part of the leading edge because when an aircraft stalls, this is the part of the wing that stalls first. This occurs so that in the initial phases of a stall, the ailerons are still able to provide roll control. Spoilers have a contrary effect to flaps and slats. They are panels on the upper surface of a wing that extend upward to disrupt the smooth airflow over the wing. As their name states, they spoil lift generation. When they're extended, immediately behind them a controlled stall is induced, thus creating enormous amounts of drag. During flight, they can be used in one of two ways: to aid roll control by providing significantly higher roll states through uneven extension of all spoilers. This feature is discussed more in depth in the primary flight controls lesson, to allow for steeper rates of descent without a significant increase in airspeed. It's not uncommon to find airliners using flight spoilers to increase their descent rate. When the aircraft is on ground, the spoilers have the following function. As a rule of thumb, the speed at which an aircraft touches down during landing is a few knots higher than the speed at which it would have taken off. This means that when the aircraft touches down, there's still a little bit of available lift in the wings. For this reason, spoilers deploy upon touchdown in order to completely destroy the excess lift and allow for the landing gear to have better adherence to the runway. This allows the wheel brakes to perform better and therefore reduce the stopping distance of the aircraft. Flaps and slats in the 737 NGX can be grouped into two categories: leading edge flaps and slats, and trailing edge flaps. In the leading edge, there are 2 flaps inboard of each engine and 4 slats outboard of each engine. This configuration is repeated on both wings. In the trailing edge, there are a series of flaps both inboard and outboard of each engine. These flaps are double-slotted, which basically means that from the trailing edge, one flap extends, and from this flap, another flap extends. There is a flap lever in the cockpit next to the throttles that can be moved to command either retraction or extension of the trailing edge flaps. The lever has detents in the following positions: up, 1, 2, 5, 10, 15, 25, 30, and 40. When the flap lever is placed in the up position, all trailing edge flaps, leading edge flaps, and leading edge slats are retracted to their normal up position. When the lever is moved from its up detent into any of the other detents, the trailing edge flaps are commanded to the respective position. It takes approximately 38 seconds for the trailing edge flaps to fully extend during normal operation. The leading edge flaps and slats are sequenced to extend and retract as a function of the trailing edge flaps position. This occurs in two stages. When the flap lever is moved from its up detent into the 1, 2, or 5 position, the trailing edge flaps move to their respective position. Along with this, the leading edge flaps extend completely and the leading edge slats extend only halfway. When the flap lever is moved to any other detent after 5, the trailing edge flaps move to their respective position. Along with this, the leading edge slats extend completely. The leading edge flaps are already fully extended. Trailing edge flaps may be controlled by one of two ways: hydraulically or electrically. During normal operation, the hydraulic system B powers all trailing edge flaps. System redundancy is provided in a way by which if there is a hydraulic system B failure, trailing edge flaps may still be operated electrically through the alternate flap extension mechanism. This will be discussed further during this lesson. When the flap lever is moved, commands are given to a flap control unit that uses hydraulic system B pressure to move the trailing edge flaps through a power drive unit, PDU. The PDU converts hydraulic pressure into mechanical force to operate the trailing edge flaps. The PDU also has a valve by which flap extension may be bypassed. Leading edge flaps and slats may be controlled by one of two ways: hydraulically or electrically. During normal operation, the hydraulic system B powers all leading edge flaps and slats. These move with respect to trailing edge flaps in the way we described previously. When the flap lever is moved, the trailing edge system sends input to the leading edge flap and slat control valve. During alternate operation, the standby hydraulic system powers the leading edge flaps and slats and operates them electrically in order to fully extend them. During alternate operation, the leading edge flaps and slats cannot be retracted in flight. The only way to do so is by authorized maintenance engineers on ground. Leading edge flaps and slats have two indicator lights in the cockpit, located below the trailing edge flap position indicator. Leading edge flaps extension. This light comes on when all of the leading edge flaps and slats are either partially or fully extended. And leading edge flaps transit. This light comes on when a leading edge flap or slat is not in its commanded position. Flaps and slats have several protection mechanisms. It's important to understand a few of these in particular. Flap load relief mechanism, leading edge auto slat function, asymmetry and skew detection, uncommanded motion detection, and trailing edge alternate flap extension. Flap load relief mechanism. This provides the trailing edge flaps with a load relief function that protects the flaps from excessive aerodynamic loads. Flap position is changed when airspeed exceeds certain limits. However, the flap lever does not move. This mechanism operates only when the flap lever is set at either 30 or 40 detent. If the trailing edge flaps are set to 40, they retract to 30 if airspeed exceeds 163 indicated knots, and they re-extend to 40 when airspeed decreases below 158 indicated knots. If the trailing edge flaps are set to 30, they retract to 25 if the airspeed exceeds 176 indicated knots, and they re-extend to 30 when airspeed decreases below 171 indicated knots. When the trailing edge flap load relief function is active, the flap load relief light illuminates. Leading edge auto slat function. The auto slat function moves leading edge flaps to the fully extended position when the system senses that the aircraft is approaching a stall condition. Auto slat operation is powered by the hydraulic system B, but an alternate source of power is also provided through the Hydraulic Power Transfer Unit, or PTU. This feature is comprehensively described in the hydraulics lesson.